This video is a review of the recurrence and financial maths topic for further maths. So here in this presentation we're going to look through the key ideas. From the study design, the key things that we need to be able to do are in relation to recurrence relations, where we're given our rule in the format shown here. And obviously A0 is always going to be our initial term or our initial amount. Then depending on the type of recurrence relation, we could either have it multiplied by something, or a constant being added or subtracted, or a combination of both. The second key area is depreciation, and so within that we have three types of depreciation that we'll look at in this presentation. Flat rate and unit cost are all ones where there's a constant amount of change, and reducing balance is when it's a percentage of the last year or the last time period's balance. And then finally, the biggest component is looking at loans and investments. And within that, we have two sort of key areas where we're looking at simple interest loans and then compound interest loans, which include examples of reducing balance, where you're making payments as well as being charged or earning interest, annuities and perpetuities. And then following on from that, amortisation tables look at the breakup of payments within a reducing balance loan or an investment where payments are made. So first up, we're looking at recurrence relations. A recurrence relation is an equation that allows you to calculate the next term when you know the current. So this is only useful when you have to find out what the next term or a sequence of values or terms are. If you needed to jump to a larger value, say term 10 or what happens after 20 years, a recurrence relation is a really long way of calculating it. It is possible, but we tend to then change something into general form. And we'll look at the general form of each of the key ideas throughout the presentation. So it's either used to model when we're talking about growth, so increasing values, or decay, which are decreasing over small periods of time. And you'll be expected to be able to calculate up to 5 recurrence relations by hand or using a calculator, but showing that working. And then we can either have a linear form, which is that constant increase or decrease, or a geometric where you're multiplying. So looking at some key sort of examples of each of these recurrence relations in relation to our first area, which is depreciation. So with flat rate depreciation, this is when we're talking about an item that has a constant amount of decrease in value over time. Quite often the question will talk about a percentage of depreciation of the initial value, but please be really careful. Look for the words flat rate or look for a percentage decrease of the original purchase price, so that you're not confusing that with reducing balance depreciation. That's a common error. And so here we have our recurrence relation version and our general equation. So if we had to jump to the value after 10 years, I would be using this general version. And so an example of depreciation, this is from the VCAA 2006 exam 2. The content here says, question 1, a company purchased a machine for $60,000. For taxation purposes, the machine is depreciated over time. 3 different methods of depreciation are considered. So firstly, flat rate depreciation. The machine is depreciated at a flat rate of 10% of the purchase price each year. So this is here, it is a percentage, but it's of the purchase price. So the first thing that we need to work out for part 1 is how many dollars will the machine depreciate annually. So that's asking us to find that value of D. So in this case, for part 1, what we're wanting to find is 10% of our purchase price, and our purchase price was $60,000. And so to work that out, we're doing 10 over 100 times 60,000. And for some of us are better working with percentages than others. We can either see that that's 0.1 times 60,000, or we need to do the 10 over 100. But when we calculate that, we end up with our depreciation value is $6,000. So our answer for part 1, 6,000. Part 2, calculate the value of the machine after 3 years. And so generally I would skip straight to general form with questions like this. So our general form with the information we've got will be VN, so the value after N number of years, will be the initial price, so $60,000, minus D, and we found out that was 6,000, times N, the number of years. So for part 2, we're being asked to calculate the value after 3 years, so we want V3, and so to get that we're doing 60,000 minus 6,000 times 3, and when we calculate that we end up with $42,000. So our value after 3 years is $42,000. And finally, after how many years will the machine be worth $12,000 in value? So now they're giving us the value and they're asking for N. And so again, using the general rule, or the general version of the rule, I'm going to say, well, my value is $12,000. And again, my initial amount minus the amount of depreciation times N, and I'm solving for N. And in this case, I end up with N is 8, so it will be after 8 years. Okay, so that's an example of flat rate depreciation. Now, unit cost. So unit cost depreciation is also a linear version. It's a constant decrease, but it's talking about units of use. So quite often we're talking about a car depreciating by an amount per kilometre of travel. And so if it travels for 10,000 kilometres and it's depreciating at 15 cents per kilometre, we're saying that's that constant amount of 15 cents per kilometre that it's travelled. So instead of N representing a year or a month, it's now representing a unit of use. So in that case, it would be kilometres. So again, look for the keyword unit cost. Once you see that, this is the set of rules that you're going to be working with. The general equation looks very much exactly the same as the flat rate depreciation, and now your unit of D, or your value of D, is just talking about the unit per use rather than per time period. So an example of that, continuing from question 1, so we still have our machine worth $60,000, and we're saying version 2 was unit cost depreciation was used. So the value of the machine depreciates by 12 cents per use. On average, the machine is used 45,000 times annually. So part 1, how many dollars will the machine depreciate annually? So what we need to work out, if it's 12 cents per use and it's used $45,000 per year. So for part 1, we're going to say D, the amount it's depreciating, will be that 0.12 times 45,000 uses. And so that gives us an annual depreciation of $5,400. So our answer there, it's depreciating by $5,400. For part 2, calculate the value of the machine after 3 years. So now we're saying we're depreciating by $5,400 per year, and we're doing that for 3 years. So we can actually now convert it to like a flat rate and say for VN, in this case will be V3, will be $60,000 minus $5,400 per year, and that's for 3 years. So our value after 3 years will be $43,800. And finally, calculate at the end of which year the machine's value will first fall below 12,000. And again, almost exactly the same setup as it was in part A of this question for flat rate, but now we're looking at our value still being 12,000. Our initial amount is still 60,000, but our annual depreciation 4,500 times N, and solving for N. In this case, we get 8.89. Now, we want to know at the end of which year, so we have to give a whole number here. At 8 years, we won't quite have reached a depreciated value of 12,000, so it's at the end of the 9th year, so or after 9 years. Finally, we have reducing balance depreciation, not to be confused with reducing balance loans. So you're looking firstly for the keyword depreciation and then the type, in this case reducing balance. In this one we have our recurrence relation is slightly different. So we're looking at the next term is found by multiplying the current term by this value of R. And our depreciation means we're losing value, so R is calculated by doing 1 minus the rate over 100. So you're looking for information about this rate of depreciation and being able to calculate R first before you can construct your equation. That big value of R, capital R, is the same as what's in the general equation. And once again, you'll most often use the general equation version for solving your values for this. Okay, so last part for question 1. We're looking now at option C is reducing balance depreciation. The value V of the machine after n years is given by the formula where Vn equals 60,000 times 0.85 to the power of n. So in this case they're giving us the general rule version of our reducing balance. So part 1, by what percentage will the machine depreciate annually? So we know that R, in this case, big R, equals 8.5. So we want to use that equation that R equals 1 minus little r on 100. And we know that that value is 0.85 and use that to find out what our interest or our percentage per annum is that we are depreciating by. And so when we solve this, 0.85 equals 1 minus R over 100, we get R equals 15%. And again, some of you are quite good with percentages and will see that 0.85 actually means 1 minus 15% without having to work out that little equation. But it's handy to have that understanding anyway. Part 2. Part 2 is asking us now for calculate the value of the machine after 3 years. So similar to before, but now we need to use this version of our rule. So our new rule is saying that the value after 3 years is given by $60,000 times 0.85 to the power of 3 for n is 3. And when we work that out, we get a value of $36,847.50. We had 15% there and 36,847.50. And part 3, again, at the end of which year will the machine's value first fall below $12,000? Once again, we're going to use our general rule. And this time our value still $12,000, but we're using the equation from the left. So 60,000 times 0.85 to the power of n, solving for n. And when we do that, we get 9.9 years. So again, at 9 years, we won't have decreased to that value, so it will be after 10 years using this value. Quite often the last part of the question might be which one is most advantageous. So it depends on the context of the question. Do we want the item to last for a long time, or do we want to get to write it off to a smaller value earlier on? So it just depends on what the question is asking you there. Okay, moving on to loans and investments. So with loans and investments, as we said, 2 key areas, simple interest and compound interest. So first up, we're looking at simple interest. With our simple interest, our recurrence relation looks very similar to depreciation with flat rate, except for one key thing. We're now adding on our constant amount, okay? So whether it is an investment where you're putting money in the bank and earning interest on it, or it's a loan and the bank is charging you interest, either way, the value is increasing. And so it's increasing by a constant amount. Again, often it'll give you an R percentage rate, but that is in relation to the initial amount. So either the principal value, what you invested or what you borrowed. So just be careful, you're looking for those words simple interest before you decide what type of formula you need. Okay, and again we have our recurrence relation version and our way of calculating D, and also our general equation, which we'll most often use. Okay, and your first step is always work out that value of D if it's not given to you. Okay, so an example here. From the same exam paper, 2006, we're looking at question 3 now. So a company prepares for this expenditure by establishing 3 different investments. Investment A, $7,000 is invested at a simple interest rate of 6.25% per annum for 8 years. Determine the total value of this investment at the end of 8 years. And so in this case, we've got our key information here. First thing we need to do is find D. So the amount of interest that is being earned each year. D is given by the initial amount, so $7,000, times the rate, 6.25 over 100. And so that gives us an initial amount of a constant increasing amount of $37.50. And so that's our value of D. Then to find at the end of 8 years, that means we're finding the value after 8 years, and using our general form, it's our initial amount, so 7,000 this time, plus D, 437.50 times N, and in this case that's 8, because we want after 8 years. And when we do that, we end up with a value of $10,500. Okay, the next one, compound interest. So here, there's no payments or anything being made. This is simply just either an interest-only loan or an investment that is earning interest. And so much like our reducing balance, we have this now value of R that we are working with. And in order to calculate R, we're given some information about the interest rate that is being earned or charged. And we have to work out our value of R first. Okay, so same example, but now option B, we have $10,000 is invested at an interest rate of 6% per annum, compounding quarterly for 8 years. So we've got our initial amount of $10,000, our rate 6%, and we can see that it's compounding quarterly. So that quarterly makes a difference when we're talking about our time period. It's there per quarter. So determine the value of the investment at the end of 8 years. So again, we want at the end of 8 years. Now the easiest way to do a question like this, even though it doesn't need any payments, is to use our finance solver and our calculator. So with finance solver, remember it is perfectly acceptable for you to write down in your exam paper the list of key values that you're putting in, because then we can see as examiners what you've actually entered to get the values. So the key things, remember, we're entering our N for the number of repayments, I for the interest rate, PV is the principal, PMT is payments, FV is your future value or the account balance, and PPY, CPY, so period, payments and compounds per year. Okay, so fill in what we know and solve for what's left. So we're doing this quarterly for 8 years. So remember, you can type into your calculator 4 times 8 and it will work out that equals 32 payments. You don't have to work that out in your head, but you can. Interest rate, 6%. Now I've invested $10,000, so I'm giving $10,000 to the bank, so I put that as a negative. I'm making no additional payments. I want to find out my future value, so that's what I'm going to come back and solve for. And it is happening 4 times a year, quarterly compounds. So when I go back and solve for my future value, I end up with a value of $16,103.24. And so this is asking to the nearest dollar. So my answer there, $16,103. So round as normal if it asks me for the nearest dollar. Part C, determine the effective interest rate for that given in Part B. Write your answer correct to 2 decimal places. So because this is compounding quarterly, even though the interest rate is given per annum as 6%, it is effectively a slightly higher interest rate, because the more often that it's being compounded, the more money I end up earning compared to if I had an investment that was at 6% per annum only. And so there is a formula to work this out, but the best way and the easiest way, unless you had to show some sort of working, is to actually use the interest rate conversions option on your calculator, or even a shorter way of doing that. If you actually type in the letters EFF on your calculator, you'll notice they turn from italic to normal, and so that tells you it's a command that it's recognizing. And we put in what the interest rate is and how many times a year it's compounding. And so when we do that and press enter, we end up getting that effective interest rate, or the equivalent interest rate that we're earning per annum if it was only compounding once a year. And so in this case, that gives us an interest rate of 16.4% per annum. Second type of loan or investments, we have compound interest, but with a payment this time. So in this case, we do have a recurrence relation where we're talking about our initial amount, and then we have something that's being multiplied, so the interest that's being earned or charged, plus the payment that's being made. Now, there is no general equation for this. Well, there is, but it's not part of our course. You always use Finance Solver for these questions. Okay, so your balance is going to be, if it's an investment, increasing every time, but it's a different amount each time period. You have exponential growth because you've got that that R value that you're multiplying by, and you're making a constant payment, which eventually will mean that either the loan is paid out or your investment reaches a certain point. So the key thing is to identify those key values for your Finance Solver, and look for those first, identify what you've got, and then work out what it is you need to solve for. So the example we've got here is continuing from previously. We've got option D was investing $500 into an account with an interest rate of 6.5% compounding monthly. Deposits of $200 are made into this account at the end of each month. Anytime payments are being made in further maths for this particular topic, they will happen at the same time period breakdown as the compounding period, so it'll always be the same. Okay, so determine the total value of this investment at the end of 8 years and write your answer correct to the nearest dollar. So again, we want to use our Finance Solver, so our key values, N, I for interest, our principal, payments, what the future value is, how many times a year is it happening. Okay, so 8 years and it's compounding monthly. So monthly, 12 times a year and 8 years, so we end up with 48 payments in total. 96 payments in total. I've written 4 instead of 8 there. Our interest rate, 6.5%. Our principal value, I'm depositing $500 in the bank. I'm making an additional payment to the bank of $200 per month, so I write both of those as negative. I want to find out the value, so I'm finding out my future value, and these are both happening 12 times a year. And so when I do that, I end up with a value here, a future value of $25,935.304, and I want this to the nearest dollar, so my answer will be $25,935. The next and most common type of application of these sorts of compound interest with payments is looking at reducing balance loans, and this is what most of us are used to seeing. So our balance is decreasing over time. We're paying the same amount into the bank, but it's reducing by a different amount each time period, so there isn't that constant amount. We have both interest being charged by the bank and payments being made by us off the loan. Our R value is calculated the same way, and again, we don't have a general rule. We use our Finance Solver and our calculator. Look for the keywords reducing balance loan. As soon as you see that, get your calculator out, check from the values in the list, what can I enter, what do I need to solve for? Okay, so question 4, same exam paper, so same sort of scenario. The company anticipates that it will now need to borrow $20,000 to pay for the new machine. It expects to take out a reducing balance loan with interest calculated monthly at a rate of 10% per annum. The loan will be repaid fully in 24 equal monthly instalments. Determine the total amount of interest that's being paid on the loan. So a key little thing to remember here is interest is equal to the total paid minus the amount borrowed. So that takes into account all of the interest the bank has charged, plus all the payments you've made, and the difference between what you borrowed and what you actually paid for that money is the interest that's been charged. So what we need to work out, we know how long the loan is going to last, so we know N is 24. We know everything else, but we need to work out what is the payment that's being made. Once we know that, we can work out the total amount that was paid, and then obviously work backwards from there to get their interest. So first thing we want to do is in our finance solver, enter what we can, solve for what we need, which in this case is our payment value. And so first up, N, we're going to pay 24 repayments. My interest rate is 10%. I've borrowed $20,000, so I have $20,000 in my pocket. It's a positive. I want to know what my payment is, so I'm going to work that one out. In order to pay off the loan, that means I let my future value be 0, and that will allow me to work out the payments required to meet that 0 balance after 24 payments are made. And these payments are happening monthly, so 12 times per year. So when I solve that, I get negative $922 and 0.899. And so that means negative, I'm giving the bank $922.90 effectively every payment. So if I take that value and now work out the total paid, so that will be 24 payments of $922.899. I tend to always go, you need to go beyond the number of decimal places needed in your answer and don't round off until the end. So here it's a bit hard to write down all of the decimal places that are given in your calc, but you want to go at least a couple past what's required so you end up with something that's accurate enough. In that case, I end up with a total payment, or the total amount paid is $22,149.56. And so now to get my interest, I'm going to do my total paid, 0.56, minus the amount I borrowed, which was $20,000. So that tells me that the interest I paid was $2,149.56 to the nearest dollar means $2,150 in total. Okay, next little application, annuities. So annuities, remember, means I have put some money into the bank and I'm earning interest on my investment, but at the same time I'm withdrawing a payment. So I'm living off that trust fund or that superannuation fund. And so the bank's paying me interest, but I'm withdrawing more than what they're paying me, and eventually my investment will run out. There's an error here. We've got look for keywords. The keywords are actually annuity. So you're looking, as soon as you see annuity, this is the type of thing. Again, there is no general rule. You're using the finance solver on your calculator. So identify the key values and then enter, solve for what's left. So in this example, new exam paper, this is from VCAA 2012, this example. So we've got Martha invested a sum of money at an interest rate of 9.4% per annum, and that is compounding quarterly. She's going to be paid $1,260 per quarter from her investment. After 10 years, the balance is now $7,000. What was the initial sum? So we want to find out what the principal value was in her particular investment. So again, we're using the same finance solver, so the same values. Let's note down what we know, and we're going to solve for our principal value. And so in this case, if we're using this information here as a basis, so after 10 years, and it's compounding quarterly. So 4 times a year for 10 years, so there's going to be 40 repayments, or 40 payments have been withdrawn from this account. The interest rate, 9.4%. We want to find out what our principal value was. She's getting $1,260, so that's a positive value there. After that 10 years, after those 40 payments, the balance is $7,000. So it still has $7,000 in it, so we write that as a positive value. And these are happening 4 times a year. And so when we solve for our present value, we end up with a negative 35,208.00254. So we can ignore that's insignificant, that value there, which means we've invested $35,208 initially. So to the nearest dollar, 35,208 initially, which makes sense. We've decreased down to $7,000 after a 10-year period. Next one, perpetuities. So perpetuities is often put into an exam paper as a trick question. The key thing, the amount of interest that the bank is paying you, so what you're earning, is equal to the payment that's being withdrawn. So your principal value will always be the same as your future value. So the balance always remains the same. You'll never have any more or any less. So, and that means it will last forever. It will never run out. So be aware of that. Sometimes you can answer the question without having to actually work anything out. So look for the keyword of perpetuity, and again, no general equation, we're using Finance Solver. So the example we've got here, again back to 2006, but this time it was a multiple choice question. So Grandpa invested in an ordinary perpetuity from which he receives a monthly pension. So each month he's getting $584. The interest rate on the investment is 6.2% per annum. But remember, we're compounding monthly. The amount Grandpa is invested in the perpetuity is closest to. So we want to know what was his principal value. Now in this case here, we actually don't need to use Finance Solver. We can just use our formula, which tells us that our V0, our initial amount, times our rate over 100 will equal our payment amount. Okay, so the information that we've got here, we know our payment amount is $584. We know our interest rate is 6.2% per annum, but we're receiving that money monthly, so we need to divide that by 12. And that will allow us to solve for what our initial amount is, or the amount that he has invested. And so when we solve for V, or V0, we end up with $113,032.26. So our investment is closest to E, 113,000. Okay, the last little part of the course is looking at amortisation tables. So this is when we're breaking down what's happening in our reducing balance loan. So when we make a payment, that payment is split into 2 things. The first part of it is paying off the interest that the bank has just added on. So it knocks out that interest that the bank has charged us. Then whatever is left goes to reducing the balance on the loan. So that's where we look at how much interest do we pay off from our payment, and then whatever's left from this payment amount goes towards reducing our principal. And then obviously what we do, we're taking that off what we already owed, and we're left with our current balance remaining. So we need to be able to do a few things. We need to be able to work out, if I know how much is owed and what the interest rate is, I need to work out how much interest is the bank charging me, and therefore how much of my payment's going towards that. I then need to be able to work out what's left, so what's my principal reduction, and then also subtract that so I get what my current balance is here. And so a couple of key sort of ideas or formulas to remember. The way that we calculate interest charged is our balance owing times our interest rate divided by the number of times a year. So if it's compounding monthly, that N would be 12. If it's compounding annually, it's 1, or we can leave it out, quarterly by 4. And that gives us my interest charge. My principal reduction, the payment I've made minus the interest charge. So what's left? It goes towards principal reduction. And then obviously the balance I owe on the loan is what I previously owed minus this principal reduction that I've calculated, gives me the current balance after that next time period. So we think that the kind of thing that you're going to be asked to do is fill some gaps like in this table here. So we've got an amortisation table. This is taken from the sample paper that VCAA have released. And what they're asking us for here is Kim has invested $400,000 in an annuity. So we can see there's an investment. And the annuity is paying 3.2% per annum. So we've given that information there. The annuity is designed to give her an annual payment of $47,372 for 10 years. So at the end of 10 years, the annuity is going to run out, effectively have a balance of 0. So for the amortisation table, the annuity is shown here, and we want to find the information that's missing. So the very first thing that we want to do up here for part A is to find the balance after that first payment has happened. And so remember, our balance of our annuity is given by the previous balance, so this $400,000 minus our principal reduction. So for part A, we're doing our 400,000 minus our principal reduction, which was $34,572. And so that gives us a balance remaining of $365,428. Next one, part B here, we're looking for the principal reduction in payment 5. So our principal reduction will be the amount we paid minus the interest that's been charged, and whatever's left will be the principal reduction. So for part B, the amount we paid, $47,372 minus the interest charged, or in this case the interest earned because we've got an investment, $8,157.81, and so the difference there, $39,214.19. So that's my reduction in principal. Okay, we can also check that if we wanted to just by finding the difference here, and that should give us the same value of 39,000. Okay, part C and D will help us with two things there. So part C is the interest earned in the 8th payment, or the 8th time period. And so to get our interest earned, remember we're doing our current balance. So in that case, at the end of the 7th, we had $133,484.14 still in the account. Times that by the rate. Our rate here was 3.2% per annum, and it was just happening yearly, so no need to divide, over 100, and that gives us the interest of $4,271.49. So that's our answer here for part C. And then obviously our principal reduction will be the amount we paid, so 4,737.2 minus our interest earned, so $271.49, and that gives us that final amount, $43,151. So we need to be able to do each of those types of things in our amortisation table, and sometimes you can work it out just by looking at the difference between some different values, and other times we need to use these formulas that we've looked at here. So quite often there's more than one way of doing it. It's just being confident of knowing what the information is actually telling you. Okay, so that's it. I hope that's been helpful to help you work out sort of the key ideas and what to expect in recurrence and financial modelling. and good luck for your